Okay, next we're going to look at how we go about securing mobile devices. So we have three basic steps involved in securing the mobile devices. First, we look at configuring the device itself. Make sure it's secure. Then we use mobile management tools to do the management of the device as far as how it's configured as well as what's loaded on it. And then lastly, configuring the device application security, those applications loaded on the device. So let's look at each of these. Firstly, we said device configuration. Again, we're going to observe our principle of least privilege. This means disabling unused features. So the idea is if it's not something that we need in the conduct of our business, it's got no business being on the phone. No pun intended. So you should disable Bluetooth wireless data communication, for example, because as we learned in last week's content, this can prevent bluejacking and blue snarfing. Remember the difference between these two, which is the more concerning? I would say blue snarfing, because that involves the theft of data and information. Bluejacking is just receiving unwanted images or text messages. Also, we would want to use strong authentication so that we can restrict unauthorized users using a screen lock, and also require a strong passcode. So we're probably all familiar with the use of the screen lock. That's a matter, of course, when you have an iPhone, for example. How does the screen lock work? Well, the lock screen prevents the device from being used until the user enters the correct password. And you can set the screen to lock after a period of inactivity. Now, I noticed just recently a video on TikTok where an individual purports to provide a mechanism by which somebody who steals your iPhone can log in, avoiding the lock screen. Of course, this is a scam. I think just loaded to see how many people he can dupe into trying this. But if you're interested, you can take a look at that. Also, after a specific number of failed attempts to enter the passcode, then we take additional security protections, because this is obviously, or potentially, I should say, somebody trying to brute force the passcode by just entering in every possible combination. So in order to fail or defeat that, the device is configured with an extended lockout period. So each time they enter, say, 3 failed password attempts, it will be locked for a progressively longer period of time, ultimately resetting to factory settings. We also can use context-aware authentication. This is where the device automatically unlocks and stays unlocked until a specific action occurs. Also, to secure the configuration of a device, we can make use of the so-called passcode or PIN, personal identification number. This can take multiple forms. It might be a 4, 5, 6, 8-digit number, or it could be entered rather than just through a keypad, a fingerprint swipe on a sensor to unlock the device. This is a draw or swipe pattern that connects the dots. This is what that looks like. So this is not a particularly secure one. Somebody could shoulder surf this, watching somebody enter in their swipe pattern to get onto an Android phone. Also, we want to look at how we manage encryption. There are significant loopholes in which mobile device data can be accessed through data in transit and remote data at rest. Remember how we talked about this back in the encryption unit. We have to secure the data both in transit and when it's stored at rest. So we'll look at both of these. For a mobile device, data in transit refers to how the carriers build surveillance capabilities into their networks to try to prevent the risks while the data is in transit, the risk of it being intercepted or viewed. Also, this allows law enforcement agencies to collect data in transit, and new mobile apps deliver over-the-top or OTT content. What is this? This is delivery of content over the internet without the telecoms being directly involved. So that's one way to secure data in transit. In other words, it's not going through the usual route where the telecoms or ISPs would be able to filter it. Also, we have remote data at rest. That was the second aspect here of how we're going to manage encryption. Apple and Google possess the decryption keys necessary to unlock data on their servers. And you've seen this in the news, how court orders are often routinely, it says here, served to Apple and Google to provide data that's stored on their servers. And if you've watched the news, you've seen Apple's been reluctant to release the keys to allow law enforcement to access that data. Users can choose to turn off the backups to iCloud or Google servers as well. Segment storage, this is another concept whereby we can use storage segmentation and containerization to put a Chinese wall, sometimes the way this is referred to separates the business data from the personal data. With containerization, we're separating storage into separate containers or blocks or administrative units, where business and personal containers are managed separately. So the advantage of doing storage segmentation is it helps companies avoid the issues, the legal issues with data ownership and privacy issues, and legal concerns that would exist because of a user's personal data, which is going to be on that same device potentially, certainly in a BYOD setting. It also, another advantage is it allows companies to delete only the business data when necessary, like when the employee leaves the organization, without touching the personal data that belongs to the employee. We'll also look at how we enable loss or theft services. So part of this is actually discussed or you actually see it in the LabSim this week. So to reduce the risk of a theft or a loss, here's some common sense precautions that you can take with your mobile device. You should keep it out of sight when you're traveling in a high-risk area. Always maintain awareness of your surroundings. Like if you're on the subway, you're on a subway car and you've got your head buried into your smartphone, you might not notice the 2 or 3 people in there that are eyeing your new iPhone 11 that's looking pretty sweet. So that's a particularly vulnerable location, a subway car, because all the thief has to do is, as they're making their way out, they can grab it and run, and then the subway car doors close and you're out of luck. So when holding the device, you should use both hands to make it difficult for that snatching to happen. And as I said, don't use the device on escalators or near subway door trains. And if you're using white or red headphone cords, that can be a problem because that's indicative, of the Beats headphones, which are expensive. So again, word to the wise is be aware of your surroundings and what you have with you. If a theft does occur, common sense, you don't want to resist or chase the thief. If a device is lost or stolen, there are security features that can be enabled to locate it. We'll talk about them on the next slide. And as you're going to see in the LabSim this week, there's a capability to do remote wiping if your phone gets stolen. Assuming, of course, that you've enabled the Find My iPhone feature, for example, if it's an Apple iPhone. So let's look at those theft services. What do we have? We have alarm, last known location, locate, remote lookout, and thief picture. This is an interesting one. Again, we see this in the LabSim. What's thief picture? This is, a thief who enters in an incorrect passcode 3 times will suddenly have her picture taken through the device's onboard camera and emailed back to the owner so you can actually see who has your phone. So this might be useful in a legal proceeding. So the alarm, it's like play a tone. The device can generate an alarm even if it's on mute. Even if it's on mute, it will generate an alarm. I think this is one of the questions you'll see in the exercises in the LabSim. Last known location. If the battery is charged to less than a specified percentage, its last known location can be indicated on an online map. You can also locate it using the device's GPS. And there's also remote, that should say lockout, not lookout. Remote lockout. The mobile device can be remotely locked and a custom message sent that is displayed on the login screen. This takes us to mobile management tools. we said we configure the device. Okay, that's now, let's say we've gone through those steps. Now we're an enterprise and we want to secure all the mobile devices that we've provisioned to our employees. So we have three areas here: the device, the applications, and the content. We want to be able to manage all three on our mobile devices throughout the enterprise. So let's look at mobile device management. These are tools that allow the device to be managed remotely. They usually involve some dedicated server, a server component that sends out these commands to the mobile devices so that you don't have to interact with the user directly. It's the server talking to the device to get the updates and so forth, or whatever is necessary to conduct the mobile device management. The client component is on the device, and that's like an agent that receives and implements the commands that are coming from the server. So an administrator can then do what are called over-the-air updates or configuration changes to selectively to one device or throughout their enterprise. So some features that they can use these tools, these MDM tools for, you can do these kinds of great things. These are all management aspects of mobile devices. Rapidly enroll new ones, do onboarding, or quickly remove them, do offboarding. Change the default device settings. Maybe a new vulnerability has been discovered and you need to quickly make those changes for all of your enterprise mobile devices. Well, if you have MDM installed, it's pretty simple. You're going to use it, you find out what the new setting has to be, and then you just promulgate it through the MDM tool. You can also use it to enforce your security requirements, and specifically encryption settings, antivirus updates, and patch management. You can also keep track of the AUP, the acceptable use policy, and make sure that that shows up before they are permitted access, so they know what they're supposed to be doing. You can also start configuring the email, calendar, contacts, Wi-Fi, and profiles using over-the-air MDM tools. And it goes on. So we can discover devices, approve or quarantine new ones, distribute and manage public and corporate apps. Basically the whole panoply of system administrator tasks that you would have needed to do in person, you can now do over the air with a mobile device management system. There's also the second one, mobile application management. So beyond the device, now we're talking about the applications, what's loaded on the device. So these are tools and services responsible for distributing and controlling access to applications. So how do we do that? Here's a term you should know. It's called application wrapping, or app wrapping. What this does is it sets up a dynamic library of software routines and adds to an existing program to restrict parts of an app. So originally, if you were going to use a mobile application management tool, it required that you used it in conjunction with the mobile device management. No longer. These are separate tools and can be used independent of each other. And the last bullet here mentions that newer versions of mobile operating systems will now have this mobile application management tool already incorporated into the OS of the device. So that's great. Now you don't have to actually go out and create this on a server somewhere with a separate procurement. And then lastly, we have mobile content management. This is used to support the creating and editing / modification of digital content by multiple employees. So why would you use this? What really do we mean by mobile content management? Well, what it's about is actually putting out information that's specific to the enterprise. Usually it might be the president's newsletter, it might be the monthly metrics, the monthly sales data, the normal reports that would be going out to you as an employee of your company. Well, a mobile content management system makes that job a lot easier. So it's not going to come out necessarily through an email, but it's going to come out in the form of delivered content from this centrally controlled mobile content management system run by your organization. So that also is a wonderful administrative tool that helps facilitate communication with your employees. And then we also want to talk lastly about mobile device application security. What about these applications, these programs that are running on the mobile devices in our enterprise? They need to be secured as well. So for applications, you can set them up so that apps can require that the user provide authentication, such as a passcode, before access is granted. So the mobile device management systems we talked about previously can do these two things to help support this kind of security: application whitelisting and geofencing. Make sure you understand the difference between these two. This shows up on the certification exam. What's the difference? Well, application whitelisting is basically like a bouncer, the way a bouncer works outside like a bar or a nightclub. They ensure that only pre-approved apps can run on the device, just like a bouncer will permit only authorized people to enter into a bar, people that are 21 or older. Geofencing, however, uses the device's GPS to define the geographic boundaries where the app can be used. An example of this might be a mobile device that's used by doctors in a hospital or nurses or physician's assistants. If that device, that mobile device, which is GPS enabled, leaves the confines of the hospital proper, it will deactivate the applications or not allow them to be used. You can't authenticate if it doesn't meet the GPS geofencing check. So that would be an example. An application whitelisting, again, is just the check against the pre-approved list, the guest list, if you will. And that list has only the pre-approved apps. So that concludes the discussion of how to secure mobile devices. The last thing we'll look at in the next video is embedded systems, how to secure that, and the Internet of Things and security thereof.